Imagine a wall of water, taller than any skyscraper, engulfing coastal cities. It's the kind of disaster most of us associate with fictional movies or distant past events. But what if I told you the recent Alaskan Fjord collapse could be a terrifying preview of what's to come? We're diving deep into the science of predicting these monster tsunamis, the forces at play behind them, and whether the next big one is already brewing right beneath the surface of the Earth. Tsunamis are some of the most destructive forces on the planet, and while we're all familiar with their catastrophic impacts on coastal communities, what you may not know is that the phenomenon behind them isn't always seismic. Recent events have shown us that massive landslides, particularly underwater ones, can unleash waves with a force greater than most imagine. This video will take you through the recent Alaskan Fjord collapse, explore the science of predicting tsunamis, and ask whether the next wave of destruction is waiting to strike. In recent months, Alaska's Prince William Sound witnessed an event so rare and so powerful that it captured the attention of scientists and emergency planners worldwide. The event we are talking about was a massive landslide in the fjord, a collapse so immense that it sent huge waves into the surrounding waters. While the impact was localized, the event highlighted a growing concern: the potential for much larger, far-reaching tsunamis caused by such landslides. Prince William Sound, located in Alaska's southeast, is no stranger to seismic activity. The area lies along the boundary of the Pacific and North American tectonic plates, which makes it prone to earthquakes. But the fjord collapse wasn't caused by an earthquake. It was the result of a landslide, a massive chunk of rock and ice breaking free from the side of a fjord and plummeting into the water below. The immense volume of displaced water then surged upward, generating a localized tsunami that sent ripples through the waters of the Sound. The scale of this collapse was immense, but it wasn't just the size of the landslide that made this event so alarming. The fjord collapse showed us how quickly a large-scale landslide could trigger a tsunami. These types of landslides happen unexpectedly, and once they do, the waves they create can travel much faster than a surface earthquake-generated tsunami. The incident in Alaska was an urgent reminder of how vulnerable coastal areas are to the forces of nature that operate under the surface. Forces we often don't see coming. The landslide that occurred in Prince William Sound may have been a rare event, but it serves as a warning sign that could have global consequences. Let's break down what happened in Alaska, how the landslide worked, and what it means for the possibility of even larger, more catastrophic tsunamis in the future. To fully understand the magnitude of the Prince William Sound collapse, we need to look at the specifics of the landslide that triggered the tsunami. A major landslide occurred in one of the fjords in this region, with massive chunks of rock, ice, and debris plunging into the sea below. When these enormous volumes of material hit the water, they displaced a significant amount of it, sending a shockwave through the fjord. The immediate consequence of this displacement was a series of waves that struck the coastline of Prince William Sound. Though these waves were localized and did not cause widespread destruction, they demonstrated how powerful such events can be. In fact, this landslide-generated tsunami was strong enough to cause minor flooding and disruption along the nearby shores. The collapse in Prince William Sound wasn't just significant because of the wave it generated. It was a stark reminder that such landslides are much more common than we might think. In fact, similar types of landslides occur in many fjords and coastal areas around the world, especially in regions that have experienced glacial retreat or significant tectonic activity. The combination of rising temperatures causing glaciers to melt and the active tectonic forces in places like Alaska could lead to more frequent occurrences of such collapses. This local event was a wake-up call for scientists. It revealed just how quickly a massive landslide can generate a tsunami and how little we know about the frequency and size of these events. To make matters more concerning, the exact mechanisms behind some of these landslides are still poorly understood. The science behind predicting tsunamis, especially those triggered by landslides rather than seismic activity, is complex and still developing. In the case of earthquakes, we have well-established methods for predicting potential tsunamis. When a massive earthquake occurs beneath the ocean, it sends seismic waves that can be detected by sensors, allowing tsunami warnings to be issued in advance. However, landslides don't offer the same warning signals. Their suddenness and unpredictability make them far more challenging to predict. Understanding how and when a landslide will occur in a fjord like those in Alaska is a daunting task for scientists. Unlike earthquakes, which involve the sudden release of energy from shifting tectonic plates, landslides are driven by a variety of factors. These include the stability of the slopes, the amount of ice present, and the rate of melting, factors that can change over time due to climate change. One of the primary challenges in predicting landslide-generated tsunamis is the fact that we don't yet have an accurate method for monitoring and measuring the stability of these fjord slopes. Scientists are increasingly using satellite imagery, drone technology, and ocean floor sensors to monitor these areas for signs of potential collapses, but predicting the exact timing and magnitude of a landslide remains elusive. Additionally, researchers are studying the way landslides behave in these environments. When large volumes of ice or rock fall into water, the resulting wave can be influenced by various factors, such as the depth of the water, the speed of the fall, and the angle of the slope. These factors can significantly affect the size and reach of the resulting tsunami. A small landslide may cause a minor wave, but a large one can create a massive wall of water that can devastate coastal areas. The threat of landslide-generated tsunamis is not confined to Alaska or even the Pacific region. In fact, similar landslides have been observed in fjords around the world, particularly in areas with a history of glacial activity. The potential for these types of tsunamis is a growing concern for coastal communities around the world. For example, in places like Norway, Chile, and New Zealand, there are large fjords that could experience similar landslide-induced tsunamis. Even more alarming, there are coastal areas where massive glaciers are retreating due to climate change, which may increase the frequency and size of such landslides. The implications of these events go beyond local tsunamis. Landslide-generated tsunamis can travel long distances across the ocean, affecting regions far from the source. Depending on the size and force of the wave, a landslide-generated tsunami could cause flooding, infrastructure damage, and even loss of life in distant coastal areas. These events are not just limited to the immediate vicinity of the collapse. They have the potential to reshape entire regions, much like the seismic tsunamis we've seen in the past. While we can predict some aspects of seismic tsunamis, the science of landslide-induced tsunamis is still in its early stages. Scientists are working to better understand the processes involved and develop better predictive models to help protect vulnerable communities. The question remains, can we predict the next monster tsunami? While scientists are making significant strides in understanding the connection between landslides and tsunamis, predicting the exact timing and location of such events is still a challenge. However, there are some strategies being developed to improve early warning systems for landslide-induced tsunamis. For one, increased monitoring of fjords, glaciers, and coastal slopes is crucial. Satellite imagery, seismic sensors, and underwater drones are helping scientists track changes in these environments. By detecting changes in slope stability or unusual seismic activity, scientists may be able to issue early warnings for local communities. In addition, improving our understanding of the dynamics of tsunami waves generated by landslides is essential for predicting their impact. By studying past events and using computer simulations, scientists can better estimate how a landslide will behave once it enters the water, which will help predict wave height, speed, and the extent of the damage. Finally, public education and preparedness are key. Communities in coastal areas prone to tsunamis must be educated about the risks and have evacuation plans in place. While we may not be able to predict the exact moment a landslide will occur, we can take steps to prepare for the worst-case scenario. The recent Alaskan Fjord collapse serves as a chilling reminder of the hidden dangers lurking beneath our oceans. While we may think of tsunamis as being caused by earthquakes, the reality is that landslides, driven by the forces of nature and climate change, are also capable of generating massive waves that can devastate coastal communities. As the science of predicting landslide-induced tsunamis continues to evolve, we can only hope that early warning systems will become more accurate and that global communities will be better prepared for such events. The terrifying truth is that these monster tsunamis are not a distant possibility. They are a growing risk, and it's up to us to better understand them before they strike.